Video, what we'll try to do is, let's say we'll be given information about a person, like information like what is his or her first, what is the sex, means whether he is male or female, then what is his age, his or her age, then what is the BMI, body mass index, then what is the region from where he or she comes, and then what are the other things, like whether he smokes or not. So we will be given this information about a person, and from that information we will be asked to predict the cost of his insurance, right? Let's say this person is going to an insurance agency and asking for his insurance. So with this information, the insurance, our model will predict the cost or price of his insurance, right? So the problem statement is, given information about a person, predict its his or her insurance cost, right? That's the problem. Cost. What is the cost of insurance, right? Because you see, when people with more age will probably have more insurance cost because they are more prone to the health issues. Again, if BMI is not proper, again people will be more prone to the health issues. So based on these factors, our model will be able to predict the cost of the insurance, right? So what here we'll have the data set, the insurance data set, right? And we'll be training our model on that insurance data set, right? And then we'll try to predict the cost, right? Okay, so let's first import the required libraries here. The required libraries are TensorFlow, of course. We'll need one more library called as pandas. Now first we'll import this dataset. Now we need to go to Google. In Google, we'll type the insurance dataset. If you type insurance dataset, you get a lot of from Kaggle. You get this link. On this link, if you click, if you go there, right? So this is the insurance dataset. And now, if we'll directly go to the GitHub from where this dataset was uh, created, dataset is created. Insurance, will create here insurance. We'll click insurance. On insurance, we'll go to raw. Right, and now we'll get this link. This link. Right? I will copy this link and paste it in while reading. Right. So what will I do? I read the data set in my pandas frame PD. So let's call it as insurance. In this variable insurance, I am reading the data set PD dot read CSV. Right. So this is pandas data frame we are creating. Insurance is the pandas data frame. In that data frame, we are reading the data from the CSV file, and I'll directly provide the URL here. Yeah. Okay, so this URL we provided here. So what we are doing here, from this URL, we are reading the data, right? This is a CSV file. This is a CSV file, right? So that's why pd.read CSV. PD stands for pandas, right? Panda, we have a function called as read CSV. That function allows us to read the data directly from CSV and create a data frame, right? Name of the data frame is insurance. Let's run it. Okay, it's taking a little longer. So after reading the data set, creating the PD is not defined. Okay, I did not execute this. First we should execute this. We have not. Then we should execute this, right? Okay, now we have got this data set in insurance data frame. Now let's print insurance dot head, first 5 rows, right? Okay, so that's what we have in the insurance data set. We have age, sex, BMI, children, number of children that person has, right? Then whether he smokes or not, region, and charges. Okay, now what we are going to do is we are going to create our x and y variable from this, right? So in x will be, so x is the independent variable and y is the dependent variable for our regression problem. In x, what will we have, right? So what we want to predict? We want to predict y, that is charges. We want to predict this, right? We want to predict this. That's the dependent variable. This is dependent on these, right? And our x will be all of this. X will be all of this, right? And y will be this, right? So, and we'll want to build the find the relationship between x and y, right? Given this x's, what is the y, right? We are going to tell our model, if this is the information, this is the charge. If this is the information, this is the charge. That's what we're going to train our model, and our model will try to find the relationship, right? How this number is coming from this, right? So model will learn the relationship between x and y, and then we'll give unknown x tuple like this, right? Any unknown tuple, and then we'll try to check whether the model predicts correctly or not, right? So first we'll split this into x and y. We'll create x and y from this. So how do we create x and y from this? Let's see. Okay, let's try to split this in. So now x is equal to, what do we want in x? We want insurance. We want this complete data frame as it is, except these charges, right? We want to drop charges. Insurance dot drop charges, right? That's what x is. And in y, what we want, y is only charges. Insurance charges. So y is another data frame, x is another data frame, right? So now if I print x and y, if I print x dot head, okay, charges is not found. It's insurance dot drop charges. Okay, so okay, what error we got? No, we need to mention the axis also, right? Yes, sorry. We need to mention the axis. Complete column we want to drop, right? Axis is equal to 1, right? Now, yeah, so that is the x now, right? So that is the x, right? So we don't have charges here. In here, we had charges, right? In insurance, we had charges. We don't have charges in x now, right? So this is x dot head, right? Similarly, if you see y dot head, you'll get only, these charges. Charges, right? Okay, now we have x and y. Now we'll try to split our x and y into training and testing, right? So what we normally do in any machine learning problem, we split the data set, right? So x will be split into two parts: x train and x test, and y will be split again: y train and y test, right? Now what we'll be using, this splitting will be 80% usually, right? I'm sorry, again it varies, depends on the problem, and this test will be 20% of the x, right? y will be 80% of the x, and this x y test will be 20% of the y. Okay, so now this what we do is normally while training, while fitting the data, will train our model on X train and Y train, right? We'll train our model on X train and Y train, and then we'll check the performance of the model by using X test and Y test, right? So this is called as test data set. So test data set is usually 30 to 20%, 20 to 30% of the original data set, right? So that's what we want to do now, right? Splitting our data set into X and Y, X train and Y train, right? Okay, so we'll use the sklearn now. We'll use sklearn library from sklearn dot pre-processing. Oh, sorry, model selection import train test split. Train test. We'll use the train test split function from sklearn, right? And we'll split our data set into X train and Y train, comma Y train, X train, comma X test. We'll write first, comma Y train, Y test. And to this we'll use train test split. Into that we'll pass X, comma Y. So this train test split will split X and Y. And we'll specify the test size here. Test size is equal to 0.2, means 20%, right? 20% is test size, and we'll also specify what is called as random state equal to, let's say, 42. So that means when later if I split the data set into again train test, I'll get the same split, right? Same split. That's what this random state means, right? So same kind of split we'll have. That's why we this is not mandatory, by the way, but if you want to have the same kind of split, same data in X train, Y train latter, so you can use this random state. Okay, so now if I run this, okay, we got the X train, Y train, and X test, Y test. Now let's look at the X train dot head, right? Okay, so now what do we want to do? I want to pre-process this data, right? What kind of pre-processing I want? First, what I want is, there are these non-numerical features. These are called as categorical features, right? XX, then this region, and this smoker. These are non-numerical features. These are categorical features. So our neural network does not understand these categorical features. We need to convert these features into what is called as numerical features, right? So we need to encode this. So we'll use one hot encoding here, one hot encoding. So what will this one hot encoding do? This will convert this categorical feature into numerical features, right? So one hot encoding. So this sex will be, we have male and female here. So the sex column will be converted into two columns. One is called as male, and other is called as female, right? So for this, this is a female, right? So male will be 0 and female will be 1 here, right? Male will be 0, female will be 1, right? And for male's column, male will be 1 and female will be 0. So this column will be split into two columns, male and female. So sex will be here, male and female. And for this, if I write it properly, so if I convert this into, so now if I encode it, it will be age will be there. It's a numerical column. The sex will convert it into male and female. Right, BMI will be there because it's already numerical. Now children, we have children already numerical, so it will be there. Then smoker will be converted into the person is either smoker or non-smoker, so that will be converted into again to smoker, non-smoker, right? So now for this row, right? This age will be 46, right? And this, whether it's male or female, it's female, right? So male will be 0 and female will be 1, right? So that kind of encoding will be, and a smoker, no smoke, smoker will be 0 and non-smoker will be 1, right? Again, region, we have northeast, southwest. So whatever number of regions we have, those many number of columns will be added here, right? So that is first thing. We want to convert the non-numerical feature into numerical feature. So we'll use one hot encoding. The other thing is I want to normalize this data. Normalize means if you see this age is having some range, BMI is having some range, right? Children is having some range, right? So now if I plot this, right? So age, if I have here age, if I plot this age against some other parameter, right? So the age will start from here. Let's say minimum age is, let's say 20, so it will go till let's say it's 80, right? So this will be age, right? Then if I plot BMI will go from, let's say, body mass index, maybe 5 for some people. It may go up to 50 or more than that probably, right? So so this scale is different, right? I want to bring all of these on the same scale, right? Let's say between 0 and 1, right? I want to normalize these parameters in this scale 0 and 1. So that is called as normalization, right? Bringing these parameters on the same scale, right? Same scale. I want to do that. So that is called as normalizing these parameters. So these are the two things I want to do. The first thing is uh, one hot encoding, and the other is normalize, right? So let's see how to do that, right? Okay. Okay, for doing this normalizing and one hot encoding, we'll use the sklearn utilities, sklearn functions. So sklearn, from sklearn, sorry, what happened? Sklearn dot compose will be importing import make column transformer. So this will help me to create a function which I'll fit on my data, that will transform the columns, right? So make column transformer uh, that will transform the columns into the one hot encoding and normalizing, right? Okay, transform the columns, right? So then from sklearn dot uh, pre-processing import mean max scalar comma one hot encoder, right? So these two libraries I need to import. Okay, now after having this, let's create the column transformer, right? That is the function which will create, right? So ct column transformer is equal to make column transformer, and to this what we'll pass is uh, what we want to do in this column transformer. We want to create the scalar mean max scalar, and that mean max scalar, to that mean max scalar, what do we want to pass? We want to pass the numerical features, right? What are the numerical features? Numerical features are, like, if you see here, they are age, BMI, and children, right? Age, BMI, and children. This you see, these we want to scale, right? Min max scalar will scale these to a same scale, right? Min max scalar, so age, then BMI, and the children, right? So that's what this min max scalar will do. And then we have one hot encoder, one hot encoder, and this one hot encoder will encode the non-numerical feature or categorical feature into the numerical features, right? So it will also ignore the ignore the unknowns, right? Ignore unknown or handle the unknowns by ignoring them, right? Handle unknown is equal to ignore. We'll write here ignore, right? And then we'll pass the categorical feature. What are those categorical feature? The first one is sex, smoker, and region, right? Sex, smoker, and region. Sex, smoker, and region. Okay, so that's the column transformer we have. Let's run it. Okay, one hot encoder object is not. Okay, so I need to put a comma there. Yeah. Okay, so this column transformer is ready. Now I'll fit this column transformer on our train data ct.fit xtrain, right? So this column transformer is fitted on our training data. Now we'll transform the training data, and we'll not fit this column transformer on testing data in order to avoid the data leakage. So ct dot, now we'll get the x train normalized x train is equal to transform ct dot transform and to this we'll pass x train, right? And then x test normal. Oh, we'll get y train normal first. Normal is equal to ct dot transform y train. So this x train normal and y train normal, they are normalized data set now, right? Let's see. So x does not contain a feature. Okay, we have here age, BMI, and children. So let's check it out. Age, BMI, children. Oh yeah, this y train normal is, this is not required actually. Y train normal is not required. Yes. So x test also will do. X test normal because in y train we do not have these features. No, in y train we have only cost, only price, right? So that's why we cannot fit this column transformer on. We cannot transform the y train by using this column transform, right? So we can do it for x train and x test because they contain these columns. X ct dot transform x test. Okay. Okay, now as we have our data ready, we'll build our model, right? We have x train normal and y train, x test normal and y test. So we'll build our model now. So model is equal to tf dot keras dot sequential, right? And build layer, we'll put the layer tf dot keras layers dot dense. Let's say we have 10 neurons in the first layer, and tf dot keras dot layers dot dense. We have 5 neurons in the second layer, and then we have tf dot keras dot layers dot, and the output layer we should have only one neuron, right? Okay, now we'll compile our model. Compile model dot compile will pass, will you define the loss here. Loss is equal to tf keras dot losses dot mae, let's say, and then optimizer is equal to tf dot keras optimizers dot sgd, let's say. Then we have metrics, let's say mae again, and then we'll fit the data, run the model, x train normal now, right, comma y train, right, and epochs equal to let's say we will train it for 50 epochs, let's say, right? Yeah. And let's see, let's run it. So our model is getting trained. You see here loss was 5033.44. Now loss is reduced, getting reduced here, and ultimately we have this loss, right? So our model is not performing well, right? So if you want to improve this model, we have to change these hyperparameters. We have to change the activation function here. For example, if I say activation is equal to, if I now I'll copy just this code as it is here for next model, just to save the time. So here, if I, this is model 1, let's say model 1 here, let's say activation is equal to, I'll change activation is equal to relu relu relu, right? And now also here, let's say increase the number of neurons here. Now here I have, let's say 10 and 1, right? And here let's say I change this to Adam, and learning rate I change, learning rate is 0.1, and epochs I'll train it, let's a little longer. And now let's, with these changes, let's run the model. Let's see what we get. Okay, okay, we made a mistake here. We are fitting and compiling the same model. This is not changed. Model 1. This has to be model 1. Model 1. Let's rerun this. Right? Okay. So the loss was, you see, the loss is reduced, fairly, 2000. We compared to previous model where the loss was, I guess we had loss here up to 5000. Now here the loss is 2000. So that's how you can train your model by changing the parameters and improve your model, right? Okay, I guess we discussed in very detail how to solve the insurance. Now, if to this you can pass the uh, you can predict by passing the parameters, x parameters to this model, right? So before that, if I print x train and x train normal, if I print x train, right, we'll have this, this, and if I x train normal dot head, if I get, right. Okay, so this is numpy array, by the way, so we'll not have this head here. But if I print x train dot shape normal, so 1000 rows and 11 columns there, and x train dot shape Okay, you see the difference here. We have here in X-ray normal we have 11 columns. Here we have 6 columns only. Because why more number of columns here? Because we transform, like the column 6 became 2 columns. Similarly, the column region might have become 3 columns, and other column like smoker became 2 columns, smoker and non-smoker, right? So that's why, right? Okay, so that was about solving regression problem, solving insurance, predicting insurance prices by using regression.